Hello. Hello, can you hear me?
Yes, sir.
Okay, good. So, yeah, before I start, any questions, any doubts about whatever has been going on about the dynamic programming thing? No doubts? Any doubts about the mid-sem paper? Are there MTech CRS students here right now?
Yes, sir.
Yeah, so did you go to the tutorial yesterday?
Yes, sir.
So are you satisfied with this discussion, or do you want some more discussion on the mid-sem?
Yes, sir. Almost every question was discussed. Yeah, every question was discussed. Yes.
Okay, good. So yeah, okay, so let's start today's class. I have decided that today's class, of course, will be a continuation of this thing that I was doing in the last class, which is dynamic programming. But instead of me giving a solution, this time you guys will do the solution. Okay, so let me share my screen and let you guys see the problem. Okay, so the first problem that we are going to solve is this famous knapsack problem. So you have a list of items. Each of them has some volume and some cost. And you have a bag, a sack kind of stuff, which has a capacity C. Okay. And you pack these items. Hello, can you see my screen?
Yes, sir.
Yeah. You want to pack these items in a bag such that there's two criteria has to be maintained. Number one, you want to pack them such that the total capacity of the items is less than C, and the cost of the items you want to maximize among the cost of the item that you are picking up. So a typical picture, something like that. I mean, okay, I don't want to go into this. So basically the input will be, so you have been given the items, each of them has a volume, so Vi, and a cost Cy. You pack this item such that the summation of Vi is less than C. I mean, some of the elements, you have to choose a subset of the elements S, and you want to maximize this element, this thing. It is exactly a real life issue problem that you have. Okay, and a typical optimization problem that has lots and lots of applications in many fields. Now, this problem is actually very hard. Okay. In general, what do I mean by very hard? Okay, I will come back to that later on in the classes. For basically, if you have no constraint on this capacity C, or the capacity C is anything, can be any the real number or something, and so are the volumes and so on, then this problem becomes what is called as NP-hard problem. So, so if you have not heard of NP-hard problem, don't worry, I will be doing them later on in this course. So this problem is actually very hard, meaning you don't expect a polynomial time algorithm for this problem. But if
Sir,
yeah,
can you
sorry,
tell me what is the knapsack problem?
okay, so knapsack problem is this one. Okay, you have been given a set of items, item 1 to item n. Each of them has a volume and you haven't given this bag capacity C,
Volume and
a cost, a
okay.
price. So when you are picking, when you are having in plane or something like that. Hello.
Yes, sir.
Yes. So when you travel in a plane or train, you have a one suitcase, right? So you're coming to ISI hostel. You have lots of valuable objects that you want to bring to ISI, but you are restricted by the fact that you can only carry one suitcase, and that suitcase has a certain volume, right? So what is it that you have to do? You want to ensure that you are taking as many things as possible which can be fit in a bag, and yet you want to maximize the amount of cost of each of the items, meaning how much value you want to put with that item. Okay, so you want to pick as many elements such that the volume of the all the objects is less than the bag's volume, and you want to carry the things that you are most valuable to you. So question is that which element should you pick, which element shouldn't you pick? Is this problem clear?
Sir, PIs are what?
VIs are the volumes
Okay.
of each item. Item I has a volume I and a cost or a price called CI.
I want CI to be maximized.
You want the sum of the CIs which you are picking to be maximized.
Okay. And given some upper bound of the volumes, right?
I have been given an upper bound of the volumes. I have been given an upper bound of the volumes. So you have to pick some items. Which items will you pick? Such that the volume set of among the items that you pick, the sum of the volumes is upper bounded by this C, and the cost of the volumes, cost of the CIs is maximized.
Okay. I got it.
Okay. Is this problem clear to everybody?
So could you please restate it?
Can
Just
I
restate it just once.
restate it just once?
Yeah.
I mean, in terms of what? Can you just tell me?
Just give me like a brief overview of what the problem statement is. That would be fine.
So it is exactly what is written. Can you see this thing that is written here? Can you see my screen?
Oh, okay. Yeah, now I can. It wasn't loaded properly. Okay.
Okay, so you have these items, item 1 to n, and you have each item has a volume and a cost. Okay, and you have a capacity, which is capital C. Your job is to pick a subset of the items such that you want some of the volume of the items that you have picked up is less than C, and the cost of the sum of the cost is maximized.
Understood, sir. Thank you.
I mean, this is exactly what you do when you are traveling. Okay, maybe the time the volume becomes the weight. Maybe. The volume becomes the weight. So in a flight you are traveling, you say that okay, you cannot take a bag more than 25 kg. Okay, so you have an upper bound, right? In that bag, you can pick at only 25 kg of items or 20 kg of items, whatever that upper bound is, right? So your job is to ensure that you don't cross the 25 kg, and yet you want to carry the most price, this most valuable of your objects, right? Or most important of your objects. And that's basically what you want to solve. Okay, so by this is a problem that is solved in almost every possible industry in some form or other. A banking sector, they want to give loans, but ensuring that okay, I can only give this much loans and I want to maximize the profit that I can get. There are constraints and you want to maximize something. So this is in various forms. This particular problem is there all over the place. Is this problem clear? Okay. So now can you please tell me how you can approach solving this problem?
Sir, we can consider all of the means all subset S and see which values are less than equals to the value C and
Right.
consider the maximum of those.
Yes, you can do that. So how much time will it take for that? What is the time complexity of that?
2 to the power n.
2 to the power n, right? So you are basically going through over all possible items that you are picking, and you are doing it. All possible subsets that are possible, that is 2 to the power n subsets. You are checking for which subsets this first constraint is satisfied, and among those constraints, you want to find the maximum of the subset that maximizes this quantity. Perfect. But now say I give you an extra knowledge that the capacity C is an integer. It's a small integer, okay, not too much big. Okay, so C is of the order n, say. Okay, so in that case, if C is of the order n, in that case, can you give me a better algorithm?
So
instead of
VI
two to
are
the power-
also integers, right?
Sorry?
VIs
Yeah, the
are also
volumes are also integers. All the volumes are integers. Can you come up with a better algorithm, better than exponential time? I can give you a hint. The hint is, of course, recursion. Okay. So you want to split up this whole problem into small parts and somehow combine them. That's the basic idea. As I told you many times in the past also, that you should always think of recursion as one of the valid ways of solving problem, as the important ways of solving problem. Okay. So maybe I will give you guys some time to think about it. How can you go about it? If you had, yeah, just think, because me giving the solution is not going to enter your head. You will just nod your head and keep quiet. So why don't you guys solve it, and in 5 minutes write a message to me saying how you are approaching it.
Sir,
Yeah.
so I will take the value of C at first 1.
What?
Then value of C is 1.
Value of capital C. Okay, that's yeah, you can, I mean, if the value of capital C is 1 and all of them are 1, then that's a trivial thing, right?
Then I will double it at each step.
What do you mean double it as a step? That's exactly what I'm asking. How do you double it? What do you mean by doubling it?
I will start by 1, then I will take 2, then I will take 4.
What do you mean by
So
that?
I-
Okay, I mean, you can take 2 and 3, but what is an algorithm? You have to give me an algorithm, right? Just saying that, oh, I'll double it.
Sir, at first we can include one item, say I include VR, comma CR, means item R. So the bag capacity will increase by C minus C1. So we can do recursion in this kind of way, that again, after including that element, we can again find another good element.
Very
Yes.
good. Can you write down the recursion and just send a message, send me a message, chat message. You have to
Yes,
write
sir.
a recursion, proper formal recursion. Now that the mid-sem is over, you cannot hand wave now. You're giving me a recursion, just define the object and send me the recursion. So as I told you, think about recursion. Recursion is like as if you have a lot of helpers with you. They can solve all the problems that are smaller than your problem. How can you make help of them and solve your problem? So instead of you solving the whole thing, how can you make your friends solve some smaller problems and you just combine them together to quickly get a solution?
Sir, will this work? Send something in the chat box.
Yes, is that always going to work? Think about it. You're kind of correct, not fully correct. So Devdatta, it is not always clear that you will have to take a eye, right? You don't know which eye is taken. And what about rest? Rest of you are completely quiet. I mean, is it just you've logged on or just
No, sir. Also, VI is less than C.
VI is less than C? Yeah, I mean, it doesn't matter. If VIs are all more than C, then that one will not be taken, right? Deborshi, you are trying to give me a direct solution that is actually a bit hard in this case. Think about breaking this stuff into smaller problems. As I told you, Ryan, think about you are kind of trying to guess which one should be put first or something.
No, the base thing, the like the least weight, I am
Not at all
populating.
clear whether the least weight has to be there or not where.
No, so I am trying to populate whatever the ideal combination would be for each weight from 1 to C, and going up to the least weight, there would not be any other possible combination below that weight because there is no item to pick within that capacity. And the first one, the optimal would be that, and then
No, but maybe, I mean, it depends upon the cost, right? I mean, if I have an
there is
item,
no other item of that weight, so that has to be picked and less than that weight. So the least weight item would be the one in if we are populating just C. And then when I go upwards along the weights, I keep updating the ideal combination through the decomposition into lesser weights. And
so what is the first thing you do? Let's think of it. You take the first, you take the least weight thing.
yes,
You're taking the least weight thing, and then what do you do after that? So,
so I am going by each from
So-
1 to C. I am running, and for the first time that I can take a item, I
You're
take that.
yes, but are you throwing it away also?
No, I am storing these all the weights and along with the optimal cost that we could accrue.
No,
So
so
I am storing that in an array. And now when I'm going upwards along the
Hold on,
weights,
hold on, hold on, hold on, hold on. So let's assume that V1 is less than V2 is less than V3 till less than Vn.
yes, okay.
Okay. In that
Okay.
case, you will first take V1.
Yes, because like the assumption is that from the capacity if C is 1 to V1 minus 1, we cannot pick any of the items. So for V1, the optimal combination is that only.
What do
The
you mean for V1? I mean for the capacity V1. Okay, fine. You are-
capacity equals to V1, yes.
Okay, but capacity equals to V. Say if I have a
V1
capacity,
plus 1, I
Yeah.
do not get to pick any other item as well. I think if I get to pick V2, then I am
No.
checking that
No,
whatever.
okay, so if its capacity is V1, say V1, the C is V1 plus 1,
Yes,
and V2 is just also V1 plus 1. Then what do you do?
yes. V2 is V1 plus 1. Okay, so I am first running the for loop from I equals to 1 to V1 plus 1 and checking whether that capacity already corresponds to some optimal cost in my array that I am updating. So I get to V1 and there is a cost of C1. I
Mhm.
store that and then I check whether V2 is higher than that or not. So I am checking along the array and a item of weight exactly that. So both of either the combinations and unique item if a single item corresponds to that weight, and I am
Yeah,
taking the max of all that.
max of all that, right? So for these
Yes.
2 items, it will be 2 to the power 2. Right. For 3 items, then there will be 2 to the power 3. So you are
No,
going
I am
back. So
running across the for loop because like each run of the for loop would take n, right?
at the end of the day, are you
Because
going to look at all the possible combinations? That's what I'm think that that's what you are doing.
no, I'm storing the array of whichever weights are corresponding to the some combination. And if there is no combination corresponding to that weight, the for loop would basically just go in and exit, or I can implement some condition. That for loop would not take any time, right? The for loop is only checking.
Can you
when
write down
there is
this? Can you write down this? Your
So I am currently
discussion?
on mobile. Okay,
Okay.
so
At least
mobile
can you
basically-
write it down in your? Oh, you have a pen and paper anywhere?
no, basically I am just out of the class in campus.
Oh, okay.
I had a class in the. Okay, I'm trying to write it down for me if I can in mobile.
Okay, I can see that other people have written something. Okay. I mean, so Rachit, what is it that you are trying to loop over?
So I'm trying to just check whether shall I take this element or not.
Okay, how are you checking that?
It will go into recursion and then it will check whether if it's not if it's not giving the maximum, then we should not take that element.
All right. If it not gives the maximum, what does that mean?
Maximum is like we are taking all the elements, we are checking
Hmm.
whether the final if we are taking those elements,
Hmm.
like if I am taking that element, if it's giving the maximum or not, like if it's giving the maximum value or not. If it is not giving, then we won't consider it.
Okay, maybe you are thinking in the right direction, but I'm not yet getting the thing that I'm more looking for. Okay, so let me try to see. I see that some of many of you have tried at least, and I am assuming the rest of you have not even tried. So you are not doing it.
Sir,
Yeah. Yes,
sir, if I partially consider the total cost of n element and total C,
Hmm.
n and C, so this can be written as Vn. Vn is the nth bag I choose, and the cost of rest of n minus 1 and total C minus Cn.
Based of n minus 1 and c minus cn. Okay, again, I think you are in the right direction.
Okay,
That-
now I am checking the Vn, the last element we are taking.
Yeah,
The
I
weight of
I
Vn is
think you are talking about in the right direction, but let me just still try to formulate it in a slightly different way. Okay, so the best way of thinking about this recursion, as I told you earlier also, is to think that you have a lot of friends and you can make them work. Okay, you are the boss. There are lots of subordinates. You can make them work and they will come back and do it. So think of it that you are trying to
Sir.
pack your bag. Okay, so let me just
Yeah.
finish my give me idea. Yeah, Thomas, you have some idea or you have some
So I'm
question?
asking,
Yeah,
sir, what are the things I have to keep input to the algorithm?
what are
This
the
is-
things you have to keep?
Yeah.
What do you mean?
I mean, what are the inputs here? The capacity.
What you tell me? I have been can you understand this whatever has been written here?
Yeah, yeah.
What-
I'm thinking that the set of all values, set of all capacities,
Yeah,
set of all costs, and the capacity, total capacity.
Yeah.
are the inputs.
yeah, that's the input. Yeah. I mean, are you still struggling to figure out what the problem is?
No, I have no idea how to think, how to proceed.
So that's it. Okay. Okay. So think of yourself that you have to pack a bag, right? You have to pack a bag and you have lots of friends. Okay, you have lots of items. So the items 1 to n. Then question is that what will you do with item n? What can you do with item n? There are only two possibilities. One, either you can pick that item n and take it in your bag, or you may not pick that item n. Right? These are the only two possibilities are there. So in that case, think of it that you tell one of your friends or subordinates, whatever you want to think of it, that see, if I am taking the pick the item n, then what is the best that I can do? What do I mean by that? So if I have picked that item n, then what is it left out? What is left? So basically, sorry. So I have the two cases, right? You can see my thing, right? So I have these items. Sorry, maybe I should write it before. I have the items, say I1 to IN. Each of them has volume V1 and cost C1, Pn and cost Cn, and you have a capacity C. Now, let's see what will you do with this last item, this last. So my job is to take the best out of all of them, right? And I have this capacity. But now question is, I pick up this, should I take this last item or not? So there are two cases. There, case one is pick IN. And I have case two, don't pick IN. Now, if I pick IN, then what do I am left with? If I have picked IN, okay, I want to question that if I am forced to pick IN and still maximize my capacity, then what is the problem? The problem reduces to see, that means I have, you can think of that I have items I1 to IN minus 1. I have capacity how much? C minus Cn, and I want to maximize it.
Sir, it is C minus Vn, not C.
Right, you are right, very right. C minus Vn, and whatever this output it, let's say this output is 1. This output is say O1. Then my output, in this case, my output will be, so my output or my gain will be O1. O1 is the output of this problem, plus I have picked up, in this case, I have picked up this last item. So that means I have also got Cn. Okay. So if a friend is there to say that, see, I think you should pick up the last item. Okay, good. Why don't you pick the last item and try to find out what is the best thing that you can do? So he says, okay, I picked last item, and then all that I'm left with this. So this is a smaller problem. I will solve it. And I can guarantee you that if O1 is the output that I can give, you will be able to carry this much amount of cost of items. On the other hand, you have the other friend who is saying that, no, don't take IE. Then what do you do? Then what is the best that you can take? How can you compute it? Remember, I have to make the problem slightly smaller.
Pick IN minus 1.
The items will just be I1 to In minus 1, and the capacity does not change, remains same, because I have not picked this one. But the number of problems, in this case, number of items is going down, number of cost capacity is going down, and my output will be something slightly more than this, whatever the output is, right? Here I have done nothing, just that size has gone small. And say this one has output 2, O2. So one friend is saying that, okay, see, I can guarantee you O2, and another friend is saying that I can guarantee you O1 plus Cn. Which one should you take? What is your final thing? What is the best that you can do?
Maximum of these two.
So max of this two, right? O1 plus Cn and O2. That is all that is there here. You split it up into two problems. Okay. So let's see formally what is it that we are talking about here. Say you have the items I1 to In. Okay. So let's define this one. IC. This is the maximum cost of items that can be packed in a bag of capacity C when the items are I1 to II. Okay. So I want to pick only I1 to II and C. Now, if you have understood it, can you write down, please, the recurrence of this? How can you write it, recurrence? And now I want to see the message from everyone. Okay, what is the recursion of KSIC? Can you please send me a message?
Sir, I is the list of items I1 through In here.
I is the which one? I
Yes,
is
small I.
small I is that. So this is saying this is a function which says that this is maximum cost when you can only pick from items I1 to II. So K10, C means you have the items I1 to I10 and you have the capacity C. What is the best you can do?
Sir, I lost my.
Hello? Hello, can you hear me now? Hello, Devarshi? Hello, rest of you can hear me now? Can you hear me?
Yes, sir.
Yes, sir. I can hear.
Okay. I think Devarshu, we lost Devarshu maybe somehow.
Hello, am I audible?
Yeah, you're audible now.
Yes, I can hear now.
Okay. So
Sorry.
KS1C is what you were saying in some sense. KS1C is that you have only one item, I1, and you have a bag of capacity C. What is the best thing you can do? Okay. Now, what is KS10C? KS10C, you have items I1 to I10, and you have a capacity C.
Okay.
Okay. So I1, yeah. So there is some ordering of I1 to IN, and I am taking this. Now, rest of you, can you please, is it clear? And if it is clear, please send me the.
Yes, sir.
Sir,
Yeah, yeah.
sir, actually, if we exclude, no, if we include the nth item, you are talking about that, right?
Yes,
So then the capacity will be C minus Vn.
yes.
What if Vn value is greater than C?
Okay, in that case, we have to throw it. We cannot. So you have to have another
So
check.
that case won't arise, right?
That case will not arise. Yes, if Vn is more than C, then case won't arise. You're right, completely right. So, I mean, for now, we can assume that all the VIs are less than C. Okay, and because if it is more than C, then with one check, you can throw away those items. The linear scan.
Hello,
Yeah, hello.
sir.
Hello.
Are you saying something?
No, I'm not saying that. Sorry.
Sir,
Yeah, I'm just waiting for you guys to send the message, which I have not got.
sir, I
from
have
you.
sent an image.
You have sent an image. I just seeing it. And yeah.
Sir, I have sent.
So was it Shantanu, right? You have sent the image, right?
Yes, sir.
Just think, is it the right thing? So
Sir,
it is.
I have sent.
Yeah, I'm just saying. I think you have just made a small mistake there. I have to compare O2 with O1 plus.
Oh, I have to add the VI. with
Yes.
the second one.
Not VIs, this CI.
The CS, the cost.
Right.
Output 1 plus.
Sir, aren't you checking your chart box?
I am checking. I'm just seeing whoever I'm finding is something not right. I'm commenting on that.
Okay.
And I'm not got it from a few people. Let me just ask now. Shubhanan Beda, are you there? Okay, the Shubhanan Beda is not even available on. I think maybe he's not there. Thomas, are you there?
Yes, sir. I have sent.
You have sent. Yes, you have sent, right?
Sir, Subanon cannot listen to the audio. He come to my room, like,
Oh, he cannot listen to the audio also.
yeah, so some problem.
Okay. Sudipto has sent. Right. Shubinoy, are you there?
Yes, sir.
Have you done?
Sir, I am trying this.
Sir,
Yeah.
in this problem also we are doing the same thing in the last class we did.
Yes. So that was the next thing I was going to ask you guys.
So
That
doing
if
comparing
you
and-
now do exactly, okay, I think people who are interested has managed to solve it. Is there anybody who has not been able to do it other than Shubhimoy and is still interested in knowing it, learning? Okay, I think either everybody has done it or
Yes, sir.
yeah.
So
Balwant,
I'm not able to solve it. Yes.
you have not been able to formulate.
Yes.
Okay, where is your problem? Can you just tell me?
Sir, are you, what are we actually trying to do? I mean, I think you were not audible to me for some, I mean, maybe I did not understand the question correctly.
No, yes, you clearly have not understood the question correctly. I think that's very much possible. I think, what are you guys seeing? I am not seeing what I am.
We are seeing the
Yeah.
image that was sent.
Yes, how do I even go out of this? Just 1 second. This image is such a painful thing. It's not. Hello,
You are audible.
Yes, sir.
Yes, sir, you are audible.
I'm audible, right? Okay.
I think you can leave and rejoin if that is possible. And
No, I'm
the
not
chats
leaving
are
and
clear.
joining. I think something got weird. I don't understand this. Just 1 second. I've just stopped my share, which is fine. Just one, excuse me, just 2 seconds. This chat message really was. Hello.
Yes, sir.
Oh God, what's going on here? Just 1 second. Oh, good. I think I managed to get it in some form. Yes, can you see my screen now?
Yes, sir.
Okay. So there's someone who told that you cannot understand. Who was it? Bishwan.
Sir, it's me, Balwant.
Yes, Balwant. Yes. So tell me, what is it your problem that's happening? So
Sir,
did you understand this term
yes.
KSIC?
Yes, sir. Yes.
You understood KSIC.
Yes.
Okay. So what is KSIC? Can you tell me in your words? What do you mean by KSIC?
Sir, KSIC is, let's say we have I items. Then
Yes.
if we are choosing from those I items, and we have a bag of capacity C.
Yes. Which
what
I
is
item?
the-
Any I
Sorry?
item? Any I item or some I item?
Some from I1 to II,
From I1 to II. Okay. Yes.
first I items.
Right.
So
Okay.
KSIC is telling me that what is the maximum cost that I can get from those
Right.
items.
Exactly. Now, did you follow this thing that was done here?
Yes, sir.
Okay, if you have followed, then tell me what is KSIC. So there are two possibilities, right? When you are packing, if you are taking elements from I1 to II and filling up a capacity C, you have two possibilities, right?
Yes, sir.
So if I follow this first one, the case one, then what is the output that I can get?
The output would be if what the output of the from I1 to II minus 1.
Yes, can you
Yes.
write? Can you tell me the output of this one in terms of KS? What is the output of this one in terms of KS?
Ki minus 1 C
Very
minus
good. KS I minus 1 C minus
C minus Vi.
C minus Vi. This is the output that I will get, and my return will be how much? Will be plus Ci
Plus Ci.
plus Ci, right? This is one possibility.
Yes.
What is the other possibility?
Other is Ks I minus 1 C.
Yes, KS
Yes,
I
yes.
minus 1 C. So this is what your friend who claims that you should take the ith back, ith element, he is guaranteeing. This is what your friend who is saying that don't take the ith element, that person is guaranteeing. So what is the actual
Maximum.
result?
It would be the maximum of both.
That's it.
Okay.
That is the recursion. Okay.
Yes, sir.
Everybody with me? Any problem? Anyone has any doubts, questions about this recurrence? So this is a very important concept. Believe me, this is something I cannot that how do you break a problem into smaller parts? This is not how we in general human beings think, and that is why you have to think in a different way. It is not a greedy algorithm. It is not like trying to guess what is the best thing that can be done, trying to do things. We are not doing a greedy algorithm. We are splitting it up into smaller subparts, right? And once you are done, then how do you finish your algorithm? How would you
If-
finish it? Yeah,
If either of these two things, number of items or the total capacity reaches 0, we need
Right.
to stop.
that is very true, right? But if you write this one as a pseudocode, what will be the pseudocode for this algorithm?
It will start with the stopping condition. So if let's say you're doing ks n comma c, then if n equals 0 or c equals 0, then output should be 0.
Right,
A check for if cn is greater than c, the one that was mentioned earlier,
right.
then output should be ks of n minus 1 c, and then else the max recursion, and then return output.
The max recursion. So in some sense, okay, I think you have understood it. And so the main issue is
So-
that if you compute this stuff and this stuff separately, then you might be computing things again and again and again, the same thing again and again. Okay, so if I just say that, oh, okay, the input is IC, so return max of, so for ks IC, return max of ks I minus 1 C minus Vi plus, what is that called? Ci comma ks I comma, sorry, I minus 1 comma C. Okay, if you write this term statement, then the algorithm will be doing the same thing multiple times. Okay, so you can understand it how by, say, I have this KSIC. Okay, so from this one, I have asked you to do I minus 1 C minus VI and I minus 1 C, right? So what will be the next thing that it will do? It will ask me I minus 2 C minus maybe VI minus VI minus 1, and it will do I minus 2 C minus VI. Now this one, when you are asking this KS of this, it will ask me I minus 2 C minus VI minus 1. And it will also ask me I minus 2 C minus VI. Now look at this, that this quantity and this quantity might be same. If VI is equal to VI minus 1, then you are basically in this branch, you are going to ask me, okay, compute KS of this quantity. And in this branch also, you will be asking KS of this quantity.
Sir,
So-
why would the rightmost branch be I minus 2 C minus VI?
This is the one in which we have not even picked up.
Then it would remain C, right?
C, it will be C, right? Yeah. Right?
Yes, sir, yes.
So issue is that this two branch will be same. So you have asked your friend to go and compute this, one friend, and another friend you have asked him to go and compute this. So this friend on himself or herself has decided to split up into another two things and ask someone to compute this. Whereas in your second friend has asked someone to compute this. And these two things, so two people are computing the same thing. And that can be very, very, very costly.
Sir, a doubt again. VI and VI minus 1 are different, right? We are
So maybe they
leaving
are
out
not.
two different
No,
elements.
maybe no. Why are we leaving out different things?
So VI is the ith element in that array of items, and VI minus 1 is the I minus 1
Yes, but
element.
they might be same, right?
Okay.
Volume of the ith element, I minus 1 element can be same.
Yes, but
If they are same,
yeah, then it's
If-
the same.
then they are same thing, right?
Yes.
Right.
Are you saying that in both cases, the set of items that will be remaining would be identical?
The set of the items will be remaining identical. Okay, so maybe
Yeah.
I should write it here very carefully. If Vi is equals to Vi minus 1, then these two are equal. Right?
Yes.
Yes, sir.
And then you will basically be computing the same thing twice. Right? That you should avoid.
But sir,
Yes.
is it always true that VI equals to VI minus
No, of course not. But this is an example that I'm saying. So in fact, if you, instead of that, if you want to write a recursion of this, if you write a recursive statement, so if this much is the time taken to compute this, then what is the time taken to compute? To how much will the time taken? Time taken will be time taken to compute this plus time taken to compute this plus 1. Right? And you see that how much will it fit there. So if I have something like T of n comma C is equals to the time taken to compute n comma ks n comma C, this will be n minus 1 C minus maybe Vn plus T of n minus 1 C plus order 1. If you solve this thing in the worst case, again, I'm not saying that this will happen always, but in the worst case, this might really blow up to exponential. This is exactly the same thing that you saw in the last class also. And the reason it is blowing up is that there are these things will be coming up in which you will be facing possibly the same thing multiple times. Okay. Is this clear? Any doubts, questions?
So would the worst case be starting with all the identical volumes?
Maybe,
Every
yes. So if all of them might be the identical volume, that can be a worst case, right?
So in general, without storing any of these updates, it would be a 2 to the power n.
Right. That's true. That's exactly the point. Okay. So without storing, this thing cannot do. Okay. So here you have done recursion. You have taken the problem, broken up into smaller problems, and you want to combine them to get back. Fine. But if you just apply plain recursion, then you will be facing a problem, because you will be doing a lot of the smaller computations. You might end up doing a lot more time in the worst case. So how to go about it? You store them.
So you're
Uh,
saying
sir,
before calculating max, store them in temporary variable.
No, not in temporary. So what should you do? Okay, so here is the DP, right? This is the recursion that you have already seen. Now, what should you do is that you should do a dynamic programming. So, for example, think of this KS. How many KSs? The KS n comma C is all that you can take, right? You make a full-fledged array or matrix. One side is n, one side is C. And then you fill this one up slowly. Note that what is the cost of filling up this point? This should contain KS 2, 4. So KS 2, 4 would be taking KS 1, something, right? Or KS 1, 4. So 1, 4 is this, and 1, something is this. So taking the max of something 2 points here, you can fill up a particular square. So here is an example. Say I1 is this one, I2 is this one, I3 is this one, I4 is this one, and I5 is this one. And the capacity is C. First of all, note that, okay, what will it be? If you don't take anything, if it is 0, meaning I am not allowing to take any item, then can you get any capacity? No, correct? So this whole row would be 0. And now from now on, now the other thing is that if you are here, you can store them also. This column also you can save. And then you can fill up this matrix from the top right, top left to bottom right, slowly, one by one, using the recurrence. Each square can be stored with, can be computed by looking at the previous row only 2 points, right? I minus 1 C and I minus 1 C minus something, C minus VI. Take the maximum of those two, you store them. So any of the squares can be filled with only constant number of operations. So what is the time taken to complete this whole thing? It will be C times n, because this is the size of the matrix. So I can fill up the C times n matrix, each taking just constant time, right? So I have an algorithm that can do it in time C times n. Note that, not 2 to the power n, C times n. Is this thing clear? Or should I repeat it again?
I don't see how it
Sure,
is
You don't see how what?
how it is like you posed a problem that we will be recalculating a lot of things and that will cause an overhead.
Yes.
How is that? How is this solving that problem?
How is that solving a? Tell me, how is it solving a problem?
How is this? How is this not doing the same thing? How is it not? How are we not recalculating the same thing over and over again?
We are not, because it is stored. Once you calculate this one, the ks2 comma 4, it is stored. This point, this you can see my cursor where. So ks2 comma 4 might be required for all the previous ones.
I see. Okay, so
But
in
there it is
recursion we were,
already stored. So I'm not computing it again.
but in recursion every single time 2, 4 was required, it was being calculated again and again.
Right.
Okay,
Exactly. That's the only
Understood.
difference with the dynamic programming and recursion.
understood.
Yeah. Somebody else had a question?
Sir, in recursion, we are going from top to down, right? Means from n comma c to n
Yes.
minus 1 c,
Yes,
like
yes.
that. But here we are going from down
Exactly.
to
You have to do
Right.
it from down to up.
so that's why we are able to
Store it. That's where you can able to store it, and whenever we require, I have all the previous things already calculated. Okay. Yes, you are right. This is, you don't do the recursion from top to down. Instead, you go from down to up. Basically, you basically fill up this whole matrix. What about rest of you guys? Oyonabo? Was it is it understandable? I cannot hear you.
Sir, I have a
Yeah.
question.
Yes.
Previously, you said that you have to assume that vi equals vi minus 1.
I did not say that. I said that if vi is equals to vi minus 1, then you might have to, these two things will be same, and then you might have to do the computation again and again.
Same
If
calculation again. and again.
yes,
So if all the vi's are different,
if all the
also-
VIs are different, then also you might end up having the same calculations again and again, depending on the combinations of VIs. Okay. I mean, it might be VI, and say if VI plus VI minus 3 is V2 plus V3, sorry, VI minus 1 plus VI minus 3, then also you'll find that this computation will come up a few times. Draw this whole tree, okay, and you'll see what's coming out.
the similarity will be some other position.
It might end up being with some other positions will come up. Okay, this one just an example where you can see that you might end up having the same thing. Same computation might have to be repeated. Okay. Yeah, Ayanabo, I cannot hear you. I cannot still hear you. So let's see some other people.
Audible?
Yeah, now you're audible. Hello.
Yes, sir.
Yeah, so is it clear?
Yes, sir. It's all right.
It's all right. Okay. Balwant,
Yes, sir.
is it, you figure out, did you figure out how it is done? You
Yes, sir.
understood?
Yes.
Okay. Shantanu?
Yes.
Okay. Okay, good. So if you guys say that you have understood it, then excellent. Okay, so by doing so, all that you take is that you have this runtime of order n times c. Okay. So that means if this c, the maximum capacity is of the order of n, then I give you a polynomial time algorithm. If C is order of n. This is much better than the exponential time algorithm that initially we started with. Okay. Yeah, so let me just, yeah, I don't want to confuse you guys more today. Okay, so this is fine. So if this is fine, let me move to the next problem, which is also in the same line, and again you guys will do it. Okay, I don't think we can do it today, so I will show it to you, explain you the problem, and then you have to think about it and you solve it. Okay, and we will discuss it on the next class. So where is it gone? Just 1 second. Yeah. So let us call this longest common subsequence problem. Okay. So basically, so this is almost something similar to this this edit problem, edit distance problem that we discussed in the previous class. But this is called longest common subsequence, meaning that you have a two sequence of say integers or English alphabets, and you want to find out the longest common subsequence. So let me give you an example. So here is a string mathematics and here is a string education. What is the longest common subsequence between these two? So for example, one can think that it can be something like ATI. Okay, so this is one possibility. Is there something longer than that? Yes, in fact, maybe E, then ATI. And here also it is E and ATI. Can we get something bigger than that? Oh God.
So it's a longer one, I guess.
Okay. Yeah, I think this is the longest one. So it doesn't have to be contiguous. It can be some collection of letters. Okay, like E and ATI, they are not connected, but it has 4 things. But here also there's a E and ATI are there. Oh, what about this one? E, ATI, and C. And here is also E, ATI, and C.
Order.
You're not respecting the order.
It is not respecting the order, right? Because this previous one, E, ATI, and C, the C should have been coming after I. But here, E, ATI, and C, the C comes before I. So this is not respecting the order. So this E, ATI, C is not a common sequence. So right now, the longest common section that we have got is E, ATI. Right? Oh, in fact, that is the one I think here. What about these things? Say villages and cities.
IES.
IES.
IES. IES. Okay. Anything bigger? I don't think so, right? So these are, of course, some toy examples that we are talking about. So again, this is also required in this biology stuffs and all those things. But for us, it's important to solve this problem. So what is it? Longest common subsequence. You have given A1 to An and B1 to Bm, and your goal is to find out the longest common subsequence between A1 to AN and B1 to PM. Okay. Is this clear?
Yes.
Yes, sir.
Okay. So because good. So I think what I will do is that I will stop today here. I want you guys to think about this problem and solve it. Please. Okay. Unless you solve it, you are not going to go anywhere. Okay. This particular props area subject seems easy once somebody solves it, but if you have not practiced it, it will be very hard. And this is a very crucial part of this of algorithms design. Okay. So please so somebody says, can we consider this edit distance with only edit? No, it's not, because it is then you have to edit from both sides in some sense, if you want to say. Okay, so it's not exactly edit distance, but it has a similar flavor. So if you have understood edit distance problem, you should be able to do this one also. So please go over it. Of course, I will upload today's videos. The yesterday's videos is already uploaded. I want you guys to go back and think about this problem, solve it. Okay, and please possibly even
So
write.
you haven't sent the slides.
I have not uploaded the slides.
Yes, sir. Yesterday's class.
Yes, sir. You uploaded just the notes you've written in the last
okay.
class.
Okay, then I will do that. So this okay.
No, sir, it's uploaded after the class started.
Oh, okay. Okay. So I think some uploading syncing was a problem, but I will check it out. Okay.
Hello, sir.
Yeah.
Before we end, there is a logistic problem, I think, regarding today's tutorial. Just wanted to let you know that probably the MTech CS interviews are going on in room 520.
Oh, then is today, when is
We
it?
can probably arrange this in 525, but I think someone from
525 is the this thing, right?
the room on the right in the 6th floor at the end. To the right.
So this
So that is also a classroom used for us.
Yeah.
So I don't think there is any class at that sort.
Yeah, there's Devoshi, can you just take care of this one? I mean, just find out a class, and if not, maybe tell them to open up the ACMU seminar room.
6th floor, right?
Yeah, 6th floor seminar room, and do it there.
Okay.
Okay, just send a message to the TS via the classroom or something like that.
Okay. Sir.
Okay, I think Shayantan only will be teaching this lecture also.
Yes.
This tutorial. Okay, so can you just maybe?
Yes, I will communicate
with him.
Yeah.
Okay, and please try this problem. Don't let it sink, sit there. Else, even the end sem exams will be. If you don't try out problems, you will not be able to do well in the end sem exam also. And this one is, as I am telling you multiple times, it's the most difficult and yet the most easy, whatever way you think of it, concept of algorithms. How to split up a problem into smaller problems. How to do this recursion. Okay, once you learn it, everything will become very simple. So please do it. We will come back on Monday. Okay, so there might be some issue on Monday, but okay, I will let you know in case there is a problem on Monday. But yeah, we will meet next time and we will do it. Okay, any questions? If not, we will stop today. Okay, so let's stop now.